Fermi Paradox. Here's something to ponder about the existence of life as we know it, given that there is a very high probability for intelligent life to exist beyond our planet, with the observable universe having a diameter of about 90 billion light-years, with galaxies numbering into billions, each of them having billions of stars as well, with an estimated number of planets to be in the trillions. There's plenty of possibility for any one of these places to harbor and foster life. But the question is, where is everybody? This is the very basic premise of the Fermi Paradox, named after physicist Enrico Fermi. The paradox was devised because of the so-called contradiction of not having any evidence of intelligent life in the universe, in spite of the overwhelmingly high probability. To sum up, here are the arguments put forth by Fermi. Number 1. There are billions of stars in the galaxy. Some of these stars are even billions of years older than Earth. Number 2. There is a high probability that some of these stars would have nearby Earth-like planets capable of developing intelligent life. Number 3. Some of these Earth-like planets may have the capability to develop interstellar travel, which is something that the people of Earth are developing at the moment. And number 4. Given that planets are far away, the Milky Way can still be traveled in a mere couple of million years. Fermi then argues that if there is intelligent life out there, well, why have they not visited Earth yet? And thus, the mystery that is the Fermi Paradox is born. True enough, even with Earth SETI or Search for Intelligent Life research on the way, there still has been no convincing proof of alien life. However, there may be a few theories that can explain the Fermi Paradox. Some are novel, while some are quite bizarre. Let's take a look. Maybe extraterrestrial life is rare or non-existent. It's also possible that other intelligent species have not arisen yet. Another possible explanation could be that aliens have yet to create technology that is suitable for interstellar travel. Some theorists suggest that maybe it's in the nature of intelligent life to destroy itself, or perhaps destroy other intelligent life forms by means of war or pollution perhaps. Maybe it's a natural progression of life to become extinct by way of natural events, just like what happened with the dinosaurs. Or perhaps intelligent life is just too far away. Some suggest that humans might not have the capabilities yet to communicate with alien life, or maybe intelligent alien life just wants to isolate itself and be left alone. Whatever the reason is, human understanding and science are a long ways ahead. Until then, we can only wonder if we truly are alone in the universe. Solar wind. Can you imagine a type of wind that's created by the power of nuclear reactions by the sun itself? Today, let's talk about the phenomenon called solar winds. Solar winds were first observed in the 17th century. Astronomers noticed that comets' tails always seem to point away from the sun, regardless of which direction the comet is taking. Solar winds begin at the sun's outer layer, called the corona. The corona can reach temperatures up to 1.1 million degrees Celsius, or 1.7 million degrees Fahrenheit. When this happens, the sun's own gravity can no longer hold on to rapidly moving charged particles comprised of protons, electrons, and plasma, as these particles move away from the star. Solar winds are primarily ejected through holes in the sun's magnetic field. These holes are called coronal holes. Other factors, such as disturbances on the surface of the sun, also affect the speed and strength of solar winds. Solar winds can reach speeds up to 800 kilometers per second, or 2 million miles per hour. As the solar wind reaches the Earth, it carries charged particles and electromagnetic waves being emitted in all directions. If the materials carried by the solar wind would reach Earth's surface, it could do some damage. But luckily, the Earth's own magnetic field provides shielding. Earth's magnetic field redirects emissions from solar winds to move around the planet. In contrast, Earth's moon, which has no atmosphere, bears the full effect of the radiation from the solar wind. In some instances, the sun releases a large amount of plasma bursts, which are known as CMEs, or coronal mass ejections. CMEs are very powerful, and they carry large bursts of radiation affecting Earth's magnetic field. Charged particles move through Earth's magnetic poles, causing light displays known as auroras. Disruptions in the Earth's magnetic field due to CMEs can also be a cause of interference with regards to Earth's broadcast and communication signals, as well as navigation tools dependent on the Earth's magnetic field. NASA's Ulysses mission, which was launched in October 6, 1990, is responsible for studying the sun at various latitudes. It has been measuring the properties of solar winds for more than a dozen years now. Another satellite that is studying the sun and solar winds is the Advanced Composition Explorer, or ACA, which was launched in 1997. The ACE keeps orbit around the Lagrange point, an area where the gravity from the Sun and Earth is equal, thus keeping ACE in a stable orbit. ACE is responsible for measuring solar winds with real-time measurements on the constant flow of particles. Neptune, the 8th planet from the Sun, coming in with a diameter of 49,528 kilometers, or 30,775 miles, and a mass of 1.02 times 10 to the 26th power kilogram, or 2.258 times 10 to the 26th power pounds, equal to the mass of 17 Earths, with 14 moons and 5 rings, and an orbit period of 60,190 days, or 164.8 years, with a temperature of approximately -214 degrees Celsius, or -353 degrees Fahrenheit. It's the farthest planet of the solar system. Welcome to Neptune. Neptune was discovered on September 23, 1846 by Ornán Leverrier and Johann Galle. Because of its vast distance, it was only in the 1800s that the presence of Neptune was determined by use of mathematical predictions. The planet spins on its axis at such a fast rate at 18 hours. Neptune is considered as an ice giant, but it is actually the smallest of them all. Despite its smaller size, Neptune is actually more massive than the planet Uranus. Its atmosphere is composed of hydrogen, helium, and traces of methane. The methane is responsible for absorbing much of the red light that hits the planet, thus making it appear blue. The climate on Neptune can be described as very active. Large storms constantly appear throughout the planet, with winds going as fast as 600 meters per second. A storm recorded in 1989 called the Great Dark Spot even lasted around 5 years on the planet. As of today, there is only one spacecraft that has flown by Neptune. That would be the Voyager 2. Besides the images of Neptune from Voyager, scientists used the Hubble Space Telescope and various ground-based telescopes to observe and study the planet. The Great Red Spot. It is perhaps the most prominent feature of the planet Jupiter, the Great Red Spot. The Great Red Spot was first observed in 1664 by Robert Hooke and then by Giovanni Cassini in the following year. Cassini described it as a permanent spot, and since then, this permanent spot was observed from 1665 to 1713 by other astronomers. Then came a 118-year-old gap until the Great Red Spot has been observed again in 1830. Some speculate that the spot observed in the early 1600s is the same as the one observed in the 1800s. And if so, this confirms that the Great Red Spot has been on Jupiter for about 350 years. In 1979, the Voyager 1 spacecraft became the first man-made object to take detailed up-close pictures of Jupiter. It is said that the Great Red Spot is actually a storm on Jupiter. It can be found 22 degrees south of the equator. It has an oval shape and spins at a counterclockwise fashion. Each rotation is roughly the same period as 6 Earth days. It measures 16,350 kilometers, or 10,159.419 miles in width, which is about 1.3 times the width of the Earth. For comparison, the biggest storms on Earth are about 1,600 kilometers, or 994 miles in width, with a speed of 321 kilometers per hour, or 199.4 miles per hour. The Great Red Spot appears to be rolling in between two bands of clouds on Jupiter. These two bands of gases are noticeable because of their differing colors. There's the brown band of clouds in the south equatorial belt, and then there's the whitish band in the south tropical zone. The Great Red Spot has a cold temperature, although it has a warm core. A possible explanation for this is that cold air arises, therefore it moves upward the vortex as it expands and cools down. As the gases cool, it creates a thick cloud over the Great Red Spot. Nobody knows for sure why the Great Red Spot is red. Sometimes, the reddish hue of the spot varies from a dark brick red to a pale salmon color. Scientists theorize that the reddish color may be the result of a combination of complex organic compounds, red phosphorus, and some sulfur. The storm's long lifespan can be attributed to Jupiter being a gas giant. The absence of a solid planetary surface prevents the storm from waning due to friction. Recent observations of the spot in 2004 reveal that the spot is actually decreasing in width, and it is estimated that by 2040, the spot will have a circular appearance. In July of 2017, NASA's Juno spacecraft successfully passed over the Great Red Spot and has sent back photos to Earth. Orbit. We've been discussing planets for a while now. Now, let's talk about planetary movement or orbit. The orbit is defined as the repeating path an object takes around another object. The object in the path is usually called a satellite. For example, the moon orbits around the Earth, so you could say that the moon is a satellite. As we previously discussed, satellites are not just naturally occurring objects, but they can be man-made as well. For example, we can look at satellites orbiting the Earth, like the Hubble Space Telescope. On a much wider scale, planets, comets, asteroids, and other objects in space also follow an orbit. The best example of this is the solar system, where the 8 planets, including our own Earth, orbit around the Sun, along with other celestial objects. Orbits come in different shapes. Although all orbits are elliptical, meaning they follow an ellipse, a round shape that is similar to an oval. Sometimes ellipses can be circular as well. Planets usually have elliptical orbits closer to being circular, while comets, on the other hand, have elliptical orbits closer to the shape of an oval. In some cases, the orbit of satellites causes them to be closer and sometimes farther. The closest point that a satellite is to Earth is called perigee, while the farthest is called the apogee. For planets in orbit, the closest point to the Sun is called the perihelion, and the farthest is aphelion. Objects stay in orbit because of gravity. Gravity is the force that objects exert on one another. The more massive an object is, the more it exerts gravity on less massive objects. Take for example the Earth's moon, which is kept in orbit by the Earth, or the solar system's planets, which are kept in orbit by the massive Sun. But why do objects stay in orbit and not get hurled off into space? Well, we have Newton's first law of motion to explain that. An object in motion will stay in motion unless something pushes or pulls it. The Sun exerts just enough gravity on Earth to keep it in orbit. It's like a constant tug of war between the satellite and the object that is pulling it back. The object's momentum and gravity must be balanced just right for a satellite to stay on orbit. If the forward momentum of an object is too much, it will move past the other object and will not stay in orbit. If on the other hand, the object's momentum is too little, the said object will be pulled down and will eventually crash towards the other. Donut-shaped planet. We're so used to seeing planets with a spherical shape, but what if we told you that other planetary shapes are possible? That's right. Given the right conditions, our understanding of physics says that a planet shaped like a toroid or donut is possible, however unlikely the probability may be. Anyway, scientists think that a donut-shaped planet may form given the following condition. If a planet spins fast enough, it may be able to generate enough centrifugal force at the equator to push the planet's sides outward, thus creating a donut shape. Of course, given this very unlikely scenario, it goes without saying that a donut planet is very unstable and can easily fall apart or be smushed into a spheroid given the slightest disturbance. So what's life like in a donut-shaped planet? Gravity in a donut planet is different from that of a spherical one. If this planet has any moons, the movement or orbit of its moon will also be different. Scientists think that the moon may move in a variety of ways, like around the planet in an elliptical fashion. The moon may also move through the planet's hole, like a figure-8 orbit. Now the sky might be different for people who are in the inner side of the donut planet. If they look up, they will not only see the sky and the stars, but they will also see the land from the other side of the donut's inner ring. Also, weather and climate is different in a donut planet. There will be times when the ring shape will completely block out the sun for some parts of the planet. If the donut planet does not have a tilt, the regions in the inner ring will mostly be dark and cold. And these are just some of the more peculiar things in a hypothetical donut planet. Think about it. Would you live in one?